This lesson introduces a record-keeping model called UTXO, which can be implemented in place of the account balance model to guarantee privacy at the subtransaction level. As a reminder, in the implementation of the account balance model, when assets were being transferred between two parties, the account balance of the recipient became visible to the sender. Non-stakeholders may gain visibility into contracts being created or fetched as a consequence of exercising a choice, and it can be addressed by implementing a different record-keeping model. UTXO stands for Unspent Transaction Output. It's a model used in blockchain technology to keep track of the cryptocurrency tokens in a user's wallet. UTXO was originally introduced in Bitcoin, and it is now used in most blockchains with the notable exception of Ethereum, which uses the account balance model. In the UTXO model, each transaction creates 0 or more unspent transaction outputs, which can then be used as inputs in future transactions. Essentially, it tracks the individual units of assets that have not yet been spent, and these units are used as the building blocks for new transactions. UTXO model is commonly used in DAML to represent assets, as implementing the model in DAML helps ensure privacy at the subtransaction level. Although the model is applied exclusively to digital coins or tokens, it is commonly represented using a physical wallet as an analogy. For instance, in a scenario where a payment of $30 is required, and your physical wallet contains a $10 bill, a $20 bill, and a $100 bill, you would combine the $10 bill and the $20 bill to cover the $30 charge. It is noteworthy that there is no need to disclose the presence of the $100 bill in your wallet to the counterparty, nor does the counterparty need to divulge the total amount in their wallet when receiving the $30 payment from you. This exemplifies the privacy and selectivity inherent in the model's transaction process. The same goes for Alice and Bob. Let's say that Alice has 3 asset contracts with the values of $15, $25, and $25. If Alice wants to transfer $30 to Bob, she can first merge her existing assets of $15 and $25 to first create $40. In this process, Alice's $15 and $25 contracts are archived, or in another word, they are spent. This $40 can then be split into $30 and $10. A $10 asset contract, which is invisible to Bob, is created for Alice, and the $30 being transferred from Alice becomes visible to both Bob and Alice in the form of Asset Transfer Proposal Contract. As Bob accepts the proposal, a new $30 asset contract is created for Bob. Since Bob's $30 and Alice's $10 asset contracts are created as a result of the transaction, they are the transaction output. Since Alice's other $25 asset contract is not involved in the transaction, it remains as is, without becoming visible to Bob. Alice's assets with the values of $10 and $25 are the unspent transaction output, which can potentially be merged and split to be spent in her future transactions. If Bob has another asset contract with a value of $100, this contract is also not involved in the transfer transaction and therefore is not revealed to Alice. To revise the account balance version of the transaction workflow to implement UTXO, a few changes must be made. First of all, in the asset template, the key and maintainer are removed, since in the UTXO model, parties must be able to keep several asset contracts of the same issuer. Asset contracts must be allowed to be merged and split for parties to create the exact transferring amount. Therefore, asset cannot be unique within the scope of issuer and owner, and the key and maintainer must be removed. In the asset transfer choice, the transfer amount field is removed and only the recipient field remains. For a party to transfer a certain amount of asset, an asset contract with the exact transferring amount will be created. Therefore, there's no need to specify the transferring amount. In the body of asset transfer choice, the asset transfer proposal contract is created with the recipient and the keyword "this," which refers to the payload of the asset contract on which the asset transfer choice is being exercised. The asset merge and asset split choices are newly added. The asset merge choice takes the contract ID of another asset contract as its parameter. The payload of the other asset is fetched to be validated. Once it's confirmed that the issuer and owner information on the payload is valid, the other contract is archived. From the payload of the other asset, the amount is extracted to be combined with the asset on which the merge choice is exercised. A new asset is created with the merged amount. The asset split choice takes an amount to be split as a parameter. It creates two new asset contracts, one with the split amount and the other with the remainder after the split amount has been subtracted from the original amount. The two newly created asset contracts are returned as a record-type split result. Split result has two fields, split asset and remainder, and it derives from the EQ and show typeclasses. Considering that the choices within the asset template encompass a proposal that includes an asset payload, the creation of a new asset, and assets encapsulated within a record, it's important to note that all these choices are consuming. As the asset's owner is the primary authority responsible for decision-making concerning the asset, they are the controller for all the choices. Finally, the asset transfer proposal is revised to have two fields, asset payload and recipient. The signatory of the proposal remains to be the same as that of asset. Passing the signatory of the asset payload as the signatory of the proposal contract is to indicate that the two contracts must have matching signatories. It can be rewritten as asset.issuer and asset.owner to serve the same purpose. Since the amount field is included in the asset payload, the ensure statement must refer to the amount of asset as asset.amount. Now the asset transfer proposal accept choice does not fetch the receiving party's account balance to create a new balance anymore. It simply creates a new asset with the recipient as the new owner by using the asset payload. By avoiding a fetch of the recipient's existing assets, the recipient's asset balance remains undisclosed to the sending party. Asset transfer proposal reject creates a new asset using the existing payload without changing any information in it. The return type is changed from contract ID asset transfer proposal to contract ID asset to indicate that once the proposal is rejected by the receiver, a new asset contract is created without assigning the receiver as the new owner. Let's test the code with a hypothetical scenario where the U.S. bank has asset contracts $700 and $300, but needs to transfer $400 to Alice and $600 to Bob. UB creates two new asset contracts with $700 and $300. Since UB intends to transfer $400 to Alice, UB exercises asset merge on the asset contract with $700 by passing the other asset contract with $300 as an argument to create a new asset contract with the amount of $1,000. UB then exercises asset split on the merged asset to split it into two new asset contracts containing $400 and $600. As a reminder, exercising asset split returns the two split asset contracts encapsulated in a record. UB keys into the split asset in the splitted UB asset record to transfer the asset $400 to Alice, which she accepts. UB keys into the remainder in the splitted UB asset record to transfer the remaining $600 to Bob, which he accepts. Finally, Alice transfers her $400 to Bob, and Bob accepts it. Let's take a closer look at this part in the transaction view. At number 80, Alice is the required authorizer of the asset transfer exercise action, which creates an asset transfer proposal contract with Bob as the recipient at number 81. At number 90, when Bob exercises asset transfer proposal accept choice on the proposal contract created from number 81, there are 3 stakeholders who can view the transaction: Bob, the required authorizer, Alice, and UB, the signatories of the asset transfer proposal contract, on which Bob exercises the accept choice. The consequence of Bob accepting the proposal is the creation of the new asset contract of $400 with Bob as the new owner. In the newly created asset contract, Bob, the owner, and UB, the issuer, are the stakeholders. Although all 3 parties, including Alice, gain visibility into the creation of the new asset contract, the only asset amount visible to Alice, the non-stakeholder, is the $400 that she offered to Bob. In the table view, Bob now has 2 separate contracts. At number 91, the letter W under Alice indicates that Alice was able to witness the creation of the contract with $400. However, at number 71, Alice cannot see Bob's other contract with $600. Alice also did not gain any visibility into the total amount of asset that Bob owns, which is $1,000. In the context of the account balance model's asset transfers between parties, a notable issue emerged where the recipient's account balance was divulged to the sender. To address this issue, the UTXO model was introduced. In the UTXO model, each transaction creates 0 or more unspent transaction outputs that can subsequently serve as inputs in future transactions. In DAML, UTXO is used to represent assets as a discrete set of contracts that, when combined, constitute the account balance, rather than a single contract representing the account balance. For illustration, this concept is often likened to a physical wallet containing paper bills. The UTXO model helps to achieve privacy at the subtransaction level and improves performance of DAML applications in terms of business transactions throughput.